Good evening, world. It is Mr. E again. We're going to do some proof practice for the midterms. Yeah, there's a few of them on there, so let's do a little practice, shall we? All right. Here's our given. BC, let's write it in. Ray BC bisects angle ABD. Let's give it. And then BC, ABC is parallel to EF. That's a given. All right, let's mark these. BC bisects. Here's BC, and that bisects. Call that a bisector. ABD. So that means that these two are congruent. And then BC is parallel to EF. So these are also parallel. Okay, well, what does an angle bisector tell us? That means that we've got, well, it gives us two congruent adjacent angles right there. So let's say what those angles are. That is angle ABC is congruent to angle CBD. That's because an angle bisector implies two congruent adjacent angles. All right, and the parallel lines give us this fact. This angle here is congruent to that. So we're going to say angle ABC is congruent to angle BEF. Because parallel lines imply, I should have, let's get rid of that. Parallel lines imply congruent corresponding angles. Oh, I guess it did fit in there. Okay, well, look at what we have here. We've got ABC is congruent to CBD, but it's also congruent to BEF. So that's going to show us that angle BEF is congruent to angle CBD because of the transitive property of congruency. And that's our proof statement. So there's our first proof. Let's do number two. How many on this? 3, 6. Okay. I'll do a page at a time for videos. Let's see. Given A is parallel to B, and 13, angle 13, is congruent to angle 6. Prove that C is parallel to D. Well, we're going to have to link these up. So we're going to say A is parallel to B. That's a given. And then angle 13 congruent to angle 6. That's a given. Well, let's see. How can we get from 13 to 6? We want to prove that C and D are parallel. Well, if those are parallel, then let's see. 6 and 11. No, 6 and 12 would be corresponding, wouldn't they? So let's see if we can't link up with that. Is 13 and 12 anything? Well, these lines are parallel. So yes, they are something. They are alternate interior angles. So we can say that angle 13 is congruent to angle 12 because parallel lines imply congruent alternate interior angles. And if that's the case, then look, we can say that angle 12 is congruent to angle 6 because of the transitive property. From this, 13 congruent to 6, and that one, 13 congruent to 12. So 12 is congruent to 6, which means that C is parallel to D because those are congruent corresponding angles. There we go. All right, let's do this. I'll get this up. Given C and D are parallel this time. 3 and 11 are supplementary. 3, I'm just going to circle these, and 11 are supplementary. Okay, angle 3, angle 11. Okay. Oh, what did I do? Hello? Is it still working? I hope so. I'm going to pause for a second and see what's going on. Okay, everything's all right. I just thought I lost something there. Okay, there's our givens. 3 and 11 are supplementary. Let's see. What's the best way to go about this? We want to prove that A and B. We want to prove that these are parallel. That's what we want to get to. Well, if those two are parallel, then we could say that 11 and 13 would also be supplementary. I'm going to prove that A and B. How can we do this? Oh, I think something did happen. Hold on a second. I need to pause just one more second. Okay, I thought I broke something on here, but I did not. Okay, let's get to this. So C is parallel to D. That means that, well, we can say that 3 and 5, or not 3 and 5. We can say that 3 and 7. Oh, let's do 3 and 5. 3 and 5 are supplementary. They are same side interior, which are supplementary. So let's go ahead and let's just do this. The measure of angle 3 plus the measure of angle 5 equals 180 degrees, because parallel lines apply same side interior. Supplementary same side interior. Here, I'll just abbreviate all that. And then 3 is supplementary to 11. That means that the measure of angle 3 plus the measure of angle 11 equals 180 degrees. Supplementary angles imply two angles with the measure. Oh, with the sum. 180. There's that. Okay, and then looky here. We can swap something out, can we? Oh yeah, let's do this. The measure of angle 3 plus the measure of angle 5 equals measure of angle 3 plus the measure of angle 11. Because they're both equal to 180, aren't they, right? So we can add them, we can set them equal to each other. Reload site. No. What is going on here? Okay. So this, we just added it. So this is, and looky here, we can cancel the measures of angle 3. Those will cancel. So now we have the measure of angle 5 is equals the measure of angle 11. Let's take a look. This is going to be subtraction. POE. Angle 5 and 11 are congruent. The measures are equal, so they're congruent. And I just proved what we already had, didn't I? I sure did. Oh, goodness. Okay, well, let's go backwards then. Let's just erase all that. I was going to the wrong ones. Oh, no. We don't need this, but we will keep these. Oh, yeah, I started off the wrong one. Man, okay. Yeah, C and D are the left and right. Okay, so 5 and 6. Wait, let's do 3. And you know what? I'm going to pause one more time. One. Oh, I'm back. Yes, I looked at the key because I was preoccupied. Let's see. Yeah, the measure of angle 5 equals the measure of angle 11 because parallel lines imply congruent corresponding angles. That's weird. That's what I was going to do first, but I don't know why I went to 3 and 5. Okay, so now we can swap out 11 and 5. So we'll say the measure of angle 3 plus the measure of angle 5. Let's make that look like a 5. Equals 180. And that's just substitution. EOE. And if 3 and 5 are 180, let's see. 3 and 5 are 180. 3 and 5. If those two are 180 degrees, that means that A is parallel to B because those are supplementary same side interior angles, which imply parallel lines.